the last problem in this set of problems, again, is still the Claes-Claiborne equation. I have a temperature, same process, of 22.23 degrees C. I have a vapor pressure of 258.9 millimeters of mercury. It this time wants me to calculate the heat of vaporization, so my delta H of vaporization. And the reason I do all this is that if you don't know what kind of problem it is, if you can write these down, a lot of times on a formula sheet, you can actually find out what it is. And it specifies that it wants it in kilojoules per mole. It tells me I have another pressure of 161.2 millimeters of mercury, and I have a temperature of 4.5 degrees C. Now this time it really does not matter which one's 1 and which one's 2 because I don't have an unknown. Again, the equation is natural log of P2 over P1 is the delta H of vaporization over R, 1 over T1 minus 1 over T2. Okay, so if I make this one, because it was the one listed first, and this one too. Okay, R, of course, is a constant, which means it's the same on every one. Okay, temperature has to be, though, in Kelvin, so I add 273 to this, and I get 295.23. Okay, plus the 273. Technically, it's 273.15. I don't usually worry about the 1.15. And this would be 277.5. Okay. For me, it's about the process, not necessarily the absolute correct answer. Alright, so natural log. I've identified 2 as being 161.2 and 1 as being 258.9. My delta H is what I don't know. R is 8.31. My first temperature is the 295.23. My second temperature is the 277.5, running out of room there. Okay, this time I have both the numerator and the denominator, so I did this as all one calculation. I just put in simply natural log parentheses 161.2 divided by 258.9 close parentheses, and I got a negative 0.4738. The delta H of vaporization over 8.31. Okay, when I do the parentheses here, I get a negative 0.0002164. Okay, now it doesn't matter, this is division, that's multiplication. I chose to do the multiplication first. So I want to isolate this delta H of vaporization. So since this is division, I want to multiply both sides by 8.31. So I make a negative 0.4738 times 8.31 is a negative 0.000164 delta H of vaporization. Okay, when I multiply those two together, I got a negative 3.937. It's still a negative 0.1232164 delta H of vaporization. Now I'm going to divide both sides by that 0.00021. So a negative 3.937 divided by a negative 0.0002164 is equal to delta H of vaporization. And so my delta H of vaporization is 18,193, but that's in joules per mole. The problem did specify it wants it in kilojoules, so I need to, the fact that there's 1 times 10 to the third joules per 1 kilojoule, I'm multiplying there, or just move the decimal place 3 to the left, it's 18.2 kilojoules per mole. And that's my final answer right there. Okay. If you don't get exactly that answer, although the 18.2 you should be fine if you don't get exactly 18,193. Again, even though I wrote down this to 4 significant digits, I usually do not I use either the answer key, or I store the number in my calculator so that I use all the digits that were given to me in the calculator. I don't count that wrong if I call it just a rounding error, and I don't count that wrong. Okay, so that is the end of section 11.2.